The identity vectors are the first step in defining the number relativity of time and distance. The identity vectors of 1 and the square root of 2 equally divide spacetime. On either side of the reference vectors, spacetime is perceived as relatively closer to or further from 1 and the square root of 2. In order to understand the relative perception of spacetime, it is necessary to gain a better understanding of the spacetime helix. The helix is formed from a simple number spiral. When the equalized perception of distance and time is applied to the simple number spiral, the result is the equalized helix. When perception is defined by the pair of reference identity vectors, the helix is transformed into a sine wave. Given that the spacetime between 1 and the square root of 2 is relative, then half of the perception is closer to 1 and half of the perception is closer to the square root of 2, which divides the wave into quadrant states. The quadrant division of the wave compares directly with the quadrant division of the infinite plane. Given that powers define spacetime perception, then the nodes and amplitudes of the sine wave are defined by the fourth roots of 2. The nodes of the sine wave are defined as the mass node and the inversion mass node, where inversion mass is an energy state. The amplitudes of the sine wave are defined as the energy amplitude node and the inversion energy amplitude node, where inversion energy is a mass state. It is important to note that the time state is the mass state, and the distance state is the energy state. The evidence for this is not presented in this video, but can be found in the ebook, The Theory of Relativity of Space, Time, and Numbers, and also in the ebook, The Proton Solution. Each quadrant of the equalized sine wave has a vector orientation. If 1 is defined to be up, then the square root of 2 is defined to be down. Each quadrant of the infinite field and the equalized wave is defined by an area perception, which is defined by the boundary velocities or ratio comparisons. If 2 is compared to 1/2, the ratio comparison is then defined as 2 divided by 1/2, which yields 4. And if 3 is compared to 1/3, then the ratio comparison is defined as 3 divided by 1/3, which yields 9. From the opposing perspective, if 1/2 is compared to 2, then 1/2 is divided by 2, which yields 1/4. And if 1/3 is compared to 3, then 1/3 is divided by 3, which yields 1/9. The area perception is then defined by the square of the numbers, or the square of the fractions, which are defined as squared velocities. The boundary lines defining the quadrant are defined by a mass number, or an energy number, or a mass fraction, or an energy fraction. The area perception of the quadrant is defined by the squaring of the velocities, which is the squaring of the mass and energy perspectives. The merging of the different vector perspectives causes a rotation of the mass and energy states, which causes a torque to emerge perpendicular to the plane. The equation for the torque is the mass number times the energy number divided by the mass fraction times the energy fraction, with the collective divided by the radius. The result is mass squared times energy squared divided by the radius. If the mass squared is viewed collectively as just mass, then the equation becomes the collective mass times velocity squared divided by the radius. Given that the velocity being defined here is the fundamental spacetime velocity, then it defines the velocity of light, or c. And if the radius is defined by the reference 1, then the equation takes on the form of Einstein's E equals mc squared. The unified area wave is an amplitude-modulated wave defined by a squared perception, which moves by the union of 1 and the square root of 2. Starting at 1, which is 1 squared, the wave moves to the square root of 2 squared, then 2 squared, and so on. In spacetime, equalized perception is fundamental, and simple integer perception is relative to equalized perception. When the identity series is compared to the squared series, it is observed that 2 and the square root of 2 squared define the same perspective state of 2, and necessarily share the same vector orientation. Given that the equalized perspective is the reference, then 2 will be fundamentally defined as a square root of 2 perspective. The identity series of 2 then alternates vector orientation every other multiple of 2. The singular nature of infinity originates a spacetime geometry and advances it infinitely. Spacetime geometry began with the infinite plane, with an upper side defined by that which is and an underside defined by that which is not. Based on the foundation of that which is and that which is not, the infinite plane divides itself into the two opposing states of time and distance. And again, based on the foundation of that which is and that which is not, time divides itself and distance divides itself to form 4 quadrant fields defined as the Higgs field. The quadrant division forms the perception of a point. The perspective of the quadrant field is defined by closer to the point or further away from the point. The perception of opposites applied to the quadrant field causes a division of the quadrant field, interior from exterior. The result is a square of perception. After the division, the internal geometry defines bounded right triangles, but the exterior is open. In order to maintain equality of perspective, the geometry of the interior is reflected onto the exterior as a mirror image. The result is a square within a square of bounded spacetime. Each boundary line of the square within a square is defined by either a 1 identity or a square root of 2 identity, which confirms them as the fundamental number pair. Boundary lines do not simply exist in an infinite plane. In order to create a line in an infinite plane, another infinite plane needs to bisect it. In order for another infinite plane to exist, the reference infinite plane has to project it. If the two lines forming the quadrant division are bisected by projected infinite planes, the result is a three-dimensional organization of planes. The boundary lines separating internal from external form an equilateral triangle. Given that the two additional intersecting planes are formed from the reference plane, then all 3 planes define a unified perspective, which means the equilateral triangle defines a unified structure. The lines of the equilateral triangle are necessarily formed from a new plane. Because the new plane is the result of all 3 intersecting planes, they will intersect each plane at an angle necessary to form the equilateral field. The new equilateral field is defined as a union field because it is formed equally from the 3 unique planar perspectives. The union field is anchored by 3 axes that equally perceptually divide the union field. Given that the union field is an energy field, and that energy fields are defined by color perception, and the perceived equal division of color is color primaries, then the 3 axes that equally divide the unified field are defined by primary colors. The unified field is defined by an equalized blend of primary color perspectives, providing a smooth transition of perspective around a neutral field center.